you're going to take the AP, and if so, what your expectations for those scores are. You know, and you stay in the course always, but we need you to understand. There's a lot. I mean, we'll say this. I've had a couple people come in, and we've gone over portions of their exams, and it always, the part from my perspective that's always frustrating is you all leave so many points on the table. There are just tons and tons of very casual, whether it's an algebra error or not recognizing how to do a question and so on. You all should be able to do much better than you start off with. Let's take a look now. And all it comes from is more practice. The more that you do a process, the more accurate you will be at that process. Period. I'm a firm believer in the more reps that you do something, the better you get at it. Take a look at that first question. Here's the function, and here's the function's derivative. And we have that domain restriction on it because the argument of a natural log can't be negative or 0. Now, write an equation for the tangent line of the graph at that point. Now, in order to give out the equation of a tangent line, what do you need to have, Josh? What do you need to have in order to give out the equation of a tangent line?
Derivative.
Which we have defined. What else do you need? Who can tell me what information we need to give out the equation of the tangent line? Noah? You need to have a point on the line, which would be an x comma y, and you need to have what the slope is. How can we get what the slope of our line is going to be? Cam? Evaluate out the derivative at whatever your x value is. So now, looking at this, I'd start off and say, well, I know half of my point is going to be e squared comma something. And to figure out the slope, I need to evaluate out the derivative at e squared. So what do I get when I plug my point in? Or sorry, what do I get as the y coordinate of the point? We got one person who can tell me, Steve? 2 over e squared. Because the natural log of e squared is 2 times the natural log of e, which is just going to be 2, divided by the input in the denominator, which was e squared. Now the next part is, write the equation of the tangent line. We still don't have the slope of our tangent line. How can we figure out what the slope of the tangent line is going to be? Go ahead. Plug e squared into the derivative. So what's the natural log of e squared going to give you? Natural log of e squared gives you 2. So it's 1 minus 2. Negative 1 over what? Negative 1 over e to the 4th. Now all you have to do is give that in y minus y1 form. So here's the point breakdown. That's what one possible equation of the tangent line is. I would presuppose you gave it in this form. Y minus 2 over e squared is equal to negative 1 over e to the 4th times the quantity x minus e squared. Is that how most of you gave it? Okay, that's fine. Any alternate but equivalent form is perfectly fine. You have now, at this point, if you've clearly indicated your work, you now have enough. You've earned 2 out of the points. Questions on that? Notice how little work needs to be shown in order to get that. If you reach those benchmarks, that's it. On the right-hand side, you get 1 point for evaluating out the function and the derivative at e squared. And your final answer is the other one. Questions on that? 2 points. You actually all should be able to get a minimum of 3 on this. For the second one, the x-coordinate, find the x-coordinate of a critical point of f. Determine whether this point is a relative max or min or neither of the function. Justify your answer. Remind me to tell you about your sign charts in just a second. What would we have to do in B in order to answer out B? We got 1, 2. Jack? What's your derivative?
1.
There you go. Set that equal to 0 means really, what are you going to be setting equal to 0? The numerator. That's it. So you could do out the cross product, that's fine, but setting the numerator equal to 0. what value, and if you need, the work that you would have to go through and show is, my numerator was, what was it, 1 minus the natural log of x? So I add this over, 1 equals the natural log of x. What's the implied base of the natural log? E. We're doing with this with the Algebra 2 kids now. E to the 1 power is equal to x. So that would mean x is equal to E. That's the first part. In order to figure out whether it's a relative max or a min, what do you need to show? Let's show out a sign chart. Now, part of this that gets frustrating is, and by the way, what inputs could you pick? I picked ones that would make it really easy, maybe like e to the 0, and then e to the first, and then e squared. And you'd evaluate it out. When you give out your sign chart, here's the problem. So here's what that would look like. I've got, and to evaluate out what's happening, this would be e, this would be e to the 0, and then this would be e squared. Are we all in agreement that that's what they could look like on a number line? Obviously not equally spaced. We're going to plug those into the derivative. When I plug e to the 0 into my derivative, where's my derivative equation? 1 minus natural log of x over x squared. So I don't have to keep moving up. You have that on your paper. Looking at that, what's e to the 0's value? 1, so it's going to be not 0. What's e to the 0's value? 1. And this would be 1 minus, what's the natural log of e to the 0 going to give you? 0. 1 minus 0 is? 1 all over 1. So that's going to be a positive value. Now over here, you're not evaluating it out there. You know what you get when you plug that in. What do you get when you plug an e in? 0. It's a critical value. You've already stated that. What about over here when I plug in an e squared? This would be 1 minus 2 over e to the second power. All that's going to end up giving me is some negative value. What is the function then doing? Well, here the function is increasing. Here it's decreasing. There's your proof. The problem that so many of you have from your last exam is you're not giving this over here. I'm seeing charts that weren't labeled. So you should not be getting points for that because we're going, well, what does that show me? They just ran. It looks like something, the ravings of a lunatic. Randomly putting charts with pluses, minuses. Oh, good. What the hell does it mean? Where's it coming from? Are you describing, is the first derivative positive, the second derivative positive? What is it? Stop saying it. It's just like a trial. If you get up there, you don't say they are guilty or the person is guilty. You say this person is guilty and you point at them, or Bob is guilty. I don't go through right now and say all of you are talking. I go through and say Mike is talking. He's probably making fun of Molly on her birthday. See? I'm making it specific. If I said stop talking, everyone looks around. If I said Mike stop talking, you all look at Mike. See? Say hello.
Mike.
Happy birthday to Molly.
Happy birthday, Molly.
See? Now, here's what gets credit. Watch all of this. 3 points. Why? And here's the other part. You can't just give the sign chart. That helps. What's the problem? Some of us are even not doing this. Stop saying it. It's less writing. And you can even say this. F prime goes from plus to minus. That's it. Some of you have to say, when I was in school, I was a little bit of a chatty Cathy. And I'll tell you this, my Italian teacher, this poor woman, who put her in an early grade. Her name was Mrs. Marola. Full name, Ermina Aquilina Marola. God love her. She was, what? Yeah. Ermina Aquilina, and she'd sit there, she was about this tall, okay? And she would yell at us. I'll text her, you are so loud. No, that was the non-Catholic school. So we would sit there, and she always would say that, she'd go, McEntee, you have diarrhea of the mouth. What an unsettling visual that is. But some of you have almost, let's say, diarrhea of the pen. You give so much with saying nothing. You go through, it goes from this to this, therefore it is this, yada yada. What's it? You didn't tell me what it is. So you give me this whole sentence, guess how much credit you get? Thank you. Make sure you give tight, concise answers. You're saying more by saying less. Don't dance around it. And I was even talking today with Ms. Goodwine about it. She was like, they really only have to show that little. And I go, yes. And she goes, it's so funny. She goes, I bet you they give you a ton of stuff when they write. I go, absolutely. Because in every other class, they tell them, write more. I'm telling you, write less. Just write smart. Use your words. Now, next one up. So that we should, in all honesty, what's going to be the error? Now, by the way, you're able to get to x equals e. How many points do you get if you don't state it that it's a maximum and give the justification?
1.
1 point. If you just state that it's a maximum and you say it goes from, you know the concept, but because you're so, for lack of a better word, pig-headed and stubborn and won't write out what it is, you get 2/3 of the credit. Is there a big difference on the SATs between getting 2/3 of the points and getting all of them? Yeah. You want to do just as good on the AP. And you don't want to get a 2 by 1 point. But if you don't write it, frankly, you should be getting a 2. Next one up for C. Point of inflection. How do we figure out where the point of inflection is? Set the second derivative equal to 0. You know the first derivative. Now let's take the second. Now, this to me, I love because it showcases how terrible some of you are at knowing your derivatives. What is the derivative of the natural log? If we don't know this, I don't know. We were discussing this before. I think I'm going to have installed, I put in a budget request, just trap doors under every desk. And there's going to be a fiery pit underneath, like in the movies. And if you get it wrong, I'm just going to hit a button up here, and you'll get dumped into the fiery pit. Maybe then we'll learn our natural or our derivative rules. Maybe then. Would that be motivation, Sam, do you think? And you know what? Maybe one time I'll make a mistake and then throw someone down and go, oh, maybe they can cut back up quickly if we get them quickly. Now, looking at what's there, what's the derivative of the natural log of x? Seriously? 2 people? 3? Is this person going to know?
Of course.
No way. Cam? 1 over x. And what do we have to do in order to take out this derivative, loves? What rule are we going to have to apply? Quotient rule. It's funny, you don't recognize it at all. So we go through low d high minus high d low. And by the way, someone's going, well, why is it negative 1 over x? What's the derivative of 1 minus the derivative of the natural log? So minus 1 over x. That's where that came from. It's not math magic. It's really not as right. We distribute out, combine like terms. What did we reduce out, by the way? What did all the terms have to go from this step to this step? Because people are going, well, where did that come from?
X.
You reduce out an x. Now, so we found our second derivative. What do we need to do to find the criticals on that?
So numerator equals 0.
Set the numerator of the whole thing equal to 0. Same thing. When does that happen? X is equal to, well, I go through, if I'm solving that equation, I would add the 3 over and divide by 2, so the natural log of x is equal to 3 halves. How do we solve for x? Exponentiate. So e to the 3 halves is equal to. So what's our, now, here's another thing. It already told you that it was, well, I'll say this. What doesn't this have on here that some of you didn't get from before? Are we guaranteed that's a critical value?
No.
Now you gotta use a sign chart.
You've got to use a sign chart and label the sides. And it's not, and why do I say label the sides? Because what should your label be on this sign chart? Double prime, yeah. And then that tells you what the function is doing. You can do concave up, concave down. If you only get to that point, in my opinion, they were very lenient on this. In my opinion, it's only a candidate for a critical value. It doesn't become a critical value until you've demonstrated that there's a sign change. And then my explanation for it would be, y double prime, is it y or f double prime? Which one is it? Y notation? F double prime changes from this to this. Therefore, there's a change in concavity there. You're smart enough to do that. Get real. Last one up. I discussed this with someone earlier when we were going through and doing it. It's a good discussion to have. The AP goes right to this. Oh, here you go. Yeah. I'm sorry. They put that on there. You have to demonstrate that. Show me how. Show me the sign chart and then a sentence. Now, we were discussing this. You're taking a one-sided limit. You can't take the full limit because it doesn't exist to the left of 1. Here's what you have to consider. Natural log, the limit of this is 0 approaches from the positive side. Natural log of x over x. Now, you're approaching from the positive side. So you're coming in, let's say, from point 1. Watch what happens if I try doing something with point 1. I have the natural log of point 1 over point 1. Okay? Now I need to evaluate this out. The natural log of point 1 is the same as saying e to this power is going to give me 0.1. If I go numbers bigger than 1, it's going to get huge. E is 2.718 and some change. If I plug in a 0, what do I get? 1. Let's try plugging in 0.1. That's saying e to this power is going to be equal to 0.1. What number has to go here? Well, you've got to get like 1 over e to like the 7th or something like that, whatever it ended up being. Let's say that this is 7. Therefore, my power would be negative 7. And so you've got negative 7 over 0.1. Is that going to be some huge positive number or some huge negative number? Some huge negative number. So take that into consideration when you're doing that. You could remember, by the way, the natural log graph, which is going to look like this. So if I'm evaluating that out at 0.1, that's going to be some really, really big negative number. Okay? You only get the point for the answer, though. There's no justifying work shown. You either know it or you don't. This is developing the concept, so you do know. Questions on what we've done so far? Now, let's go through, please, and go over to your note packets. Fill in on the front. What's today's date, loves? What is it? 19th. All right. So go in, please. Fill out. We're on day 2. Is that right? We talked about the integral. The integral collects the area under the curve between your graph and the function itself. Between your graph and the x-axis. It collects all that space. Some shapes are really easy to take, some shapes are not. And last time we had class, we talked about using Riemann sums. Now, for our stuff today, here's the parts that we need to go through and get. We should be on page 7. Looking at what's there, let the function be continuous. Now, this is a whole bunch of language. It's getting used to what an integral is and integral notation. We're saying the function is continuous on there between some a and b. And let a and b be partitioned into n subdivisions. So that's saying the function that I'm graphing, maybe it's, is continuous from a to b. So it would have to look, let's say, like this. Okay? A to b. Now, I'm going to partition that into n subdivisions. Like 5, 10, 15. By the way, what happens to the approximation of the area under the curve as n gets bigger? It gets more accurate. Looking at that, but they're all of equal length. That's another thing that you have to know. We make them of equal length. Now, what this is saying is, to figure out what this area is, let's ask this. What can you do to make the area under the curve more accurate if you're dividing up into n subdivisions? Hands up, please, when you can tell me. You're trying to get as accurate of an approximation as you can. What needs to happen to those n subdivisions in order to get the most accurate estimation possible of the area under the curve? We got 1, 2 people? What do you have to do? You know, Jeff? Make as many as possible. What this is saying is, if I take the limit as this sum goes out to infinity, that's saying I'm evaluating out almost an infinite number, because probably after the 1,000th subdivision, like is there going to be a ton of difference if you go from 1,000 to 1,001? Probably not. You start getting really, really close, such that the difference is going to be insignificant. The more subdivisions you add, the better it is. If you take it all the way out to infinity, you're left with that notation. That's called an integral. And we read it as, because this is one of these things, we're going over it, especially with the 11th graders, there's this part, this dippiness that they think is adorable, because they don't know how to say log. They're going, log 27? You mean the log of 27? No, we need the 2 like down low. So log low 2 big 7, or the log of 2 to the 7. Use appropriate language. This is, the way we say it is, the integral of f of x from b to a. The b is the upper bound, or the rightmost point. The a is the lower bound. So we're saying it, it goes the integral of f of x from b to a. That means you're collecting the area under the curve of f of x from b to a. Not difficult. Now, in words, this means that the number, or as the number of rectangles approaches infinity, the sum of them approaches the actual area, and to find that actual area, it's the integral or antiderivative. Make sure this gets down, and let's make sure, please, we have our phones away. Now, it's very important. You know how to do this already. The antiderivative gets you the area under the curve if you're given the function. We spent the first half of Calc doing the deriv. Now we're going to do the antideriv. Looking at what we have, we talked before, all the ways we've done so far talked about Riemann sums. Now we're going to go through and work on actually collecting the area. Riemann sums was around before calculus. Calculus rendered Riemann sums obsolete. Calculus uses Riemann sums to get the most accurate estimate possible. Here's what you need to know. The upper number is the end of the interval that you're collecting under the curve. The bottom number is the start of the interval, or the lower limit. The function is called the integrand, or integrand, whichever you choose. And then whatever variable that you're taking the integral with respect to. Sometimes there's dy's. dx collects the area going left and right. dy would collect the area between your function and the y-axis. But then everything's in terms of y. And that becomes really cool, because we're going to get to do, like, think about like a washer. Does anyone know what that is? Like the machine part, or like a, what's that on? Is a washer the thing that goes on the end? No, a nut on the end of a screw, right? Think about that shape. We're going to be able to collect that, and if you think about it, and actually if you take a look in the back, somebody did it for their last project in the back. See that one that's hanging? See how the axis that they're working off of is a Y? See the blue one that's hanging down? That they caught a fish, so they made a three-dimensional fish? That's spinning around the Y-axis, not the X. So technically we'll do it later. It's collecting the volume, not the area. But it spins around.
This one.
No, the fish, the one on left. You probably can't even see it because the slices are going left and right. The one all the way to the left. Okay, sorry.
The hanging fish.
The one on the left, the one that's hanging from the stick. The fish that they caught. That's rotating, and that would not be a dx problem. That would be a dy problem, because you're collecting your rotation, or the area that you're collecting is going around this way, not going up and down. Now, you're going to be doing it at the end of the year. That's your end of your project. Oh, God, you guys are such wimps. Now, good. Yes, please do. Drop out. Looking at what we have, the next one up, If y equals x is a non-negative function, then the area under the curve is equal to the area that we would get by taking the antiderivative and evaluating it out. This is how we get that area under the curve. Now I'm evaluating this one out. This one you don't need to use calculus methods in order to get. Sketch on your paper right now a set of axes. We're starting to collect the area under the curve. Did I give you the picture or not? Look at this question. Did I give you the picture or not? I don't know. No, okay. You're going to sketch right now a set of axes. Keep in mind, we're going to graph out this function from, where does it start at? From 1 to, what is it, 5?
4.
4? Okay. Go through right now. That means I'm going to be in quad 1, so sketch out 2 axes. Evaluate out the function at 1. Evaluate out the function at 4, and you can do that because this is linear. And no, you don't need a calculator to do that.
Just do 2 and 3 as well. Or...
I would, to make sure that you see what's happening there. It should be linear, however. Might put the phone away. Now, what is the value of the function at 1? Take a look at what's there. Evan, what's the value of this function at 1? What's the value of the function, Molly, at 5? Oh, sorry, is it 4 that it goes up to? Sorry, what's the value of the function at 4 then? I'm sorry. 11. So you've got at least 2 points to plot on there, 1, 5, and 4, 11. It's going to be a line so you can connect it. But John asked previously, should I find those other 2 points? You can. Plug in a 2, plug in a 3, and you're going to make it linear. You can use the side of your calculator to make sure that it's a nice graph. Now, you're going to collect the area under that curve. What shape will you have if you're collecting the area between that line and the x-axis? What shape are you going to be taking the area of if you're collecting the area between your line and the x-axis? What shape is that going to be? Hannah 1? Not a triangle. Trapezoid. Yeah, you could view it, by the way, as a rectangle and a triangle. This is what I have. Now, if I'm trying to evaluate out the integral, I'm collecting all of this area. So, what needs to get done in order to collect all of this area? We've got a basic shape that you should have been doing since geo. How do I take the area of this shape? Hands up, please, if you can tell me. The area of this trap, what would we have to do? We got no person so far. Thomas, how do you take the area of this trapezoid? Do you remember the formula? Who remembers what our formula is? Wow. Adam, do you know the area of a trapezoid? Let's say this. If you don't know it, what shapes could you divide it up into? Then do that right now. Divide it into a triangle and a rectangle. If that's what it takes, do it. If that's what it takes, do it. Hands up, please. And actually, no, we'll do this. I'll prompt you on the calculator for it. Adam, go through and sign in, please. Documents, class, quick poll. We're going to have you enter an expression. Go through right now. Enter your area. Should be getting about 23 answers. So far I've got 0. That's disappointing. Figure out what the area is. We got 1, 2. Let's get going. I don't need units or anything. I just need you to put the number that is the area. What's the value of the area? Input that, submit. We've got 9. 11. Come on. 14. This is not difficult. This isn't calculus. This is 10th grade math. We've got 16. Show. Got 18 of us. I don't get why this is taking so long. And this is really, really disappointing. Not good at all. Look at what we have. If you don't know the formula, here's the formula now. 1/2 of base 1 plus base 2. You average the bases and then multiply it by the height. So my height on one side is 5, the height on the other is 11. Add them together, you get 16. 16 times 1/2 times 3 would give me 16 times, or 8 times 3, which is going to give me 24. If you did it out this way, this shouldn't be, again, how high is this square or rectangle here going to be? What are the measurements? 5 by 3, which means this has an area of 15. Over here, what's the height going to be then here? 6. And then what is the length of this base going to be? 3. 1/2 base times height. Add them together. That's not difficult. If you can't do that, we've got big issues. Get that formula down if you don't have it already, though. Questions on what we did there? Now, let's bounce over, please, to the next page, looking at what we have. You're going to, now, this is another one that I always find a little bit funny. We're collecting the area under the curve of this function. Does anyone know what that's going to look like when you graph it out? The square root of that? John?
It's going to start at the x-axis and go like that.
Careful. It's not, it's a, you're not, if you're right, you're to describe part of the movement. When we do this out, this is going to be half of a circle. Okay? It's the upper half of a circle. So it starts up and then goes down. But here's an easy way to do this. Does this go from -2 to +2? Is that right? Okay. Pick values that are going to be easy for us to get outputs on. Go through, let's start off. What value on this interval can I plug in and easily get an output on? See, Catherine? -2. What do you get when you plug in a -2? 0. So put down, graph the point, -2, 0. What's another point I can get the output on easily for this? Hands up, please, when you can tell me. Yes? +2. What's the output when you plug in a +2? 0. Who can give me one more point that's going to be really easy? Abby? 0. What do you get as an output when you plug in a 0? 2. So you've got 3 points. -2, 0, 2, 0, and 0, 2. Connect them with an arc. How would you compute the area under that curve? Between that curve and the x-axis. What do you need to do to compute the area of that curve? We've got 2 people. Oh, how did you get out of geo? God, what are they doing to you in that class? 3 people? 4? Sam? No, because that's going to give you an approximation. Evan? What's that? How do you figure out the area of a circle? Who can tell me how we figure out the area of a circle? Mike?
1/2 pi r squared.
Area? Oh, for the final? Okay. You go through the area of a circle is pi r squared, and then we need to take half of it. What's the r for our circle?
2.
2. So what's 1/2 times pi times the radius squared going to give me? 2 pi. So what's the area under this curve going to be? 2 pi. You have to know your shapes, guys. And maybe if you don't know them, make flashcards. See? They literally did this study came out, it wasn't this year, it was 2 years ago. We were at an event last night, and I was looking. They said, and this is something to pass, well, so you understand how your brain works. They said going through, if you let students go through their notes for 2 hours before an exam, they do worse than if you gave the student, and the student had 10 minutes with flashcards before the exam. Because with the notes, it's in front of you. You don't get how much, and we're talking it's not even close. They did 88% better than the students who looked at their notes for 2 hours. Because when you see it, the answer's on the paper. It's not helping you. You need to be making flashcards. Now, let's take a look at our next grouping here. The interval is divided up into that amount. Okay? So, if the interval 1 to 3 is divided up into n subintervals with that equal length, m of k would go through and represent the midpoint of the k in subintervals. What is this asking you to do? Express this limit as an integral. What does the limit as we go out to infinity of this represent? When you see a limit, you're dividing subintervals up into infinity. What is that really telling you to take? We already went over it in the beginning of class. What? Area under the curve. And what do we use to find the area under the curve?
Antiderivative.
Antiderivative, the integral. Now, when you do this out, in our example, we're taking the integral. What's the lower bound and what's the upper bound on our integral according to the directions of this question? -1 to 3. And it's of this function. So what would the function that you're taking the antiderivative of be? Who can convert this into an integral? We got note takers? Take a look. What do you think that would convert to? This is not, you'll see the answer, but not being able to make that connection, I guess, or that attempt is going to be what's concerning. What do you think it would be? Leah? Take a guess. We said before that this is what's happening from -1 to 3. You're taking the integral of what? You're taking the antiderivative of what function? What do you think this would convert into? And we should be able to handle it. It's not, I don't know, you've got to see, that's really telling you to take n subintervals, but make the subintervals go to infinity. So as the subintervals get more and more, what do those subintervals collect? The area under the curve. And as they go out to infinity, you start to approach what the exact area under the curve is. And how do you figure out the exact area under the curve? You go through and use the integral, or antiderivative. Now, it's possible for that area under the curve to be negative. What has to happen in order for it to be negative? The function has to dip below the x-axis. If those spaces are negative, that's what we would go through and get. Now, there's two ways of doing this. You could say that this would be equal to, because some of you would go through and collect this information out, it's equal to that negative area, or it's the negation of the integral would give you out what the positive area is. Because the answer to this, when we do it, if you get a negative number, it's technically not negative area, it's area with an orientation or direction. So if it's positive, you're above. If it's negative, you're below the x-axis. The next one up, what happens if it has both positives and negatives? You have to go through and break it up. You have to go through and break it up. So, if I'm doing this out, if that's what's on your paper, how many areas under the curve do we have to go through and take? You could go through and take 3 of them, because you'd have the one that's to the left, which is below, the one in the middle, which is above, and the one to the right, which is below. Which of those would be negative? Which of the R's would be negative? 2 people. Take a look at what's there. Which R's are going to be negative? Jack? Close. Oh, wait, did I label it? Yes, sorry, R2 and R3. Both of those will be negative. The integral takes that into consideration. The integral takes that into consideration. Sometimes you have to divide it up. If you don't have the calculator, maybe. And sometimes you do. Now, here's one that's the most interesting. The integral of a constant. Now, the integral of a constant is going to be kind of easy. You did this already. Think about if you graph out a constant, like y equals 5. and you're collecting the area under it from 1 to 2, what shape would that create? A rectangle. So it's going to be really easy. Base times height. So if you're taking the integral of 4 from 7 to 1, you're making a rectangle because 4 is a constant. It's flat. How wide is that rectangle going to be? How many units across is our rectangle? 6 units. Times how high is it? How high is it? No, 4. It's literally just this. That's what happens when you've got a constant. Questions on that? Now, let's see for this next one. Go through right now, please. Yeah, go through right now, please, and do this problem out. But I need you to write it as an integral. Read this question, please. Go through and write this out as an integral. What is that going to look like if we write this out as an integral? Hands up, please, if you can tell me. What's this going to look like if we write it out as an integral? Kanji, what do you think? The integral? Okay, of what? Because that is a constant, you're going to get a rectangle. Do you remember we did that problem yesterday? That's the integral to do that. Now, let's ask this. Hands up, please, when you get the joke. Who's got why this? You'll get it. Keep it to yourself. Hands up, please, when you get it. You got 3 people who get it? 4, 5. You'll get it. You'll get it. What's the joke? And why? What? If you go from A to A, how much area under the curve can you have? So how many friends do you have? 0. See? Get it? Get it? Wonderful way. Write that in each other's yearbook. You're a real integral from A to A. Your future is from the integral from A to A of f of x. You're a big old... Now, looking at the next one, we're going to go through and do this, and I find this to be so interesting to see if we get it or if we don't. Looking at what's here, now, did I give you the graph of the sine? Yeah. So looking at what's there, tell me, by the way, how high does the sine graph go to? What's the max that the sine graph is going to reach? 1. And how low does it go? So what I'm going to tell you all is this. Looking at what we have here, what do you think the area is going to be if I go from pi to 2 pi? Take a look at that graph. How much do you... Oh, sorry. We know that the area up under the curve... This is another thing you need to make sure you know. The area under the curve, put your pencil now at 0, and trace it out to pi. How much area under the curve do we know that is? What did we state? The area under the curve is from 0 to pi. How much? 2. Gives it to you. What's the integral then from pi to 2 pi going to be? Hands up, please, when you can tell me. What's the area under the curve going to be from negative pi to 2 pi? What's the value of it going to be? Not 2. Steve? Negative 2. Why is it negative 2? Because it's under the curve. Next one up. What about the area under the curve of sine from 0 to 2 pi? Who can tell me what that's going to be? You know that from 0 to pi is 2. What's the area from 0 to 2 pi going to be? We've got 1, 2 of us. 3? 0. Why is it 0? Yeah. What about the next one? The area under the curve from, and trace it on the graph if you need to, from 0 to pi over 2. Hands up, please, if you can tell me how much you think that's going to be. We got 1 person. 2? Why is it 1?
Because if you know from 0 to pi is going to be 2, 0 to pi over 2 is half of the distance.
This area here is 2 units. This one here is 2 units, except this is negative because it's below the x-axis. How much area have I covered to go from here to here? Well, how much of the hump there do you have? Half of it. What's half of 2 then? 1. Next one up, this is the one that's the most interesting to see if you get. Looking at this next bit, we have to go through and you've got to evaluate out 2 plus the sine of x. What's that causing to happen to your sine graph? What's that? No, it's not a horizontal shift. Steve? Vertical shift, up. So you're going to take your sine graph and go up 2 units. Now, in order to do that out, will this let me go to the left? Looking at what ends up happening, here's what you have. I took my sine wave and shifted it up 2 units. I'm collecting the area from, what is it from in this one? 0 to pi? Right? From here to here? How much is it from here to here? This upper wedge here, how big is that? How much area under the curve is it? From 0 to pi, that top section of it. We stated before, this right here is 2. How big is this rectangle down here? Sorry, it's not a rectangle. What is it? No? I even have the wrong thing down, I think. I do. How high is this? How wide is it? So what's the area of this? 2 pi. So what's the area under that curve going to be? Now, take a look at the next one. All we did to evaluate this out, now there's more than one way you can view it, but all we did, pull the 2. If there's a multiple in front, you can take that and put it out front of the integral. What's the value of the integral from 0 to pi? How much area happens from 0 to pi? 2. You know that from the beginning, which means this would be 2 times 2, which is 4. Now, you're lucky because the calculators that you have will evaluate out integrals. Go into your working screens right now, please. Go in. Now, we're going to figure out where this is together. Make sure you're in a doc. We're going to evaluate these ones out. On the Nspire, go in and press, I think you have to hit menu, then drop down to calculus, which is 4. Which one do you think you're going to evaluate?
Numerical.
Numerical integral, so select that. And the rest is fill in the blank. So do it. The first one, we'll start at the first one, then go to the second and the third. Hit enter.
Are we doing the first one in exploration one or the first one that says integrals on the calculator?
Integrals on the calculator. If you're doing, come here, let me see what you're getting. Because there's some,
We have to do-
well, most of the time, just so you know, we type in sine, S, and you have X times that.
Yeah,
What's it
that's
supposed to be?
That's what I did.
Wait a minute.
X sine X.
Wait, please. Hang on. Let me go back here. Which one's you guys? Here? You didn't do X times.
I thought we just.
Do X times the sine of X if you're not getting it out right. Hang on. Let me show.
Oh, there.
So, hang on. Stop. Where's yours, John?
I don't know. Top left. Unmute, please.
Top left. Here we go. So, what did he do differently to go from this to this? X times the sine of X.
Yeah, I thought it was six X.
No. Now, and by the way, is this wrong too, or are those the right constraints? Okay, now enter the next one. And then do the third one. You're going to be doing these by hand too, just so you know. What's hilarious about it? Yeah, I know. Just like if I wanted the right answer, I wouldn't ever call on any of you guys. That would be most efficient, right? It's a good burn. I'm on fire today. First the trapdoor comment, now this. Should have my own Netflix special. Are we going to enter the third one or not?
Yeah, I was just ready.
Don't bother. Do you know how long these used to take when you're an OG like me? No calculator? I was West Side, East Arcadia, class of 99. Oh. So can you figure out what those values are? Sure. How many friends do you have? How many? How many?
0.
Yeah, because it's from A to A.
Right.
You can really,
Can't be any-
it's not, I don't think it's too late to go back and amend your senior quote.
Yeah, I think it is actually.
Oh, it is? That's too bad. So, you all know what your homework is? Math Excel. Maybe I'll go through it and close it off tonight.
Right now. I'm throwing it.
If you do, I will break you.
I'm going to throw your in.